One of the brightest stars in our night sky is dying right now. And it has been hiding a secret for more than 100 years. We only just found it. Betelgeuse, the giant red star sitting on the shoulder of the hunter Orion, one of the most recognizable stars in all of human history, is not what we thought it was. It is not alone. It has a companion that no one could see, and that companion may explain everything strange Betelgeuse has been doing, including the event in 2019 that made the entire world think a star was about to explode and light up our sky like a second moon. Astronomers have watched Betelgeuse for centuries. They named it, mapped it, studied it, argued about it, and through all of that time, a secret sat right beside it, so close and so faint that even our best telescopes couldn't pick it out. In December 2024, that changed. And what they found, once they finally looked hard enough, was bigger than anyone predicted. This is the story of the most dramatic, most bizarre, most groundbreaking developments in the history of one of the most famous stars in the sky. And it is all unfolding right now. Let's start with what Betelgeuse actually is, because the numbers are almost impossible to wrap your head around. Betelgeuse is a red supergiant star sitting roughly 650 light years from Earth in the constellation Orion. On a clear night, you can spot it with the naked eye. It's the distinctly reddish-orange point of light on Orion's upper left shoulder. It is hung there every winter night for the whole of recorded history. The ancient Egyptians saw it. The Greeks built the figure of Orion around it. Every civilization that has ever looked up on a winter night has seen this star. But only now are we beginning to understand what it truly is. Betelgeuse is enormous. Not just big, but enormous in a way that makes every comparison feel useless. The sun itself is huge. More than 1 million Earths could fit inside it, a fact you've probably already heard. But here's something you probably haven't. If Betelgeuse took the sun's place at the center of our solar system, its surface would stretch out past the orbit of Jupiter. Earth would be swallowed deep inside the star. Mars would be inside it too. The asteroid belt would sit within it. Jupiter, the largest planet in our solar system, would barely graze the outer edge of the star's atmosphere. That's the scale we're talking about. Betelgeuse is somewhere between 700 and 1,000 times wider than our sun. Its diameter spans over 1 billion miles. It puts out more than 100,000 times the energy of the sun. It's one of the largest and most luminous stars visible to the naked eye from Earth. And it is dying. When stars as massive as Betelgeuse burn through their fuel, they don't simply fade, they explode. A supernova, specifically a core collapse, type Tasuno supernova, is what occurs when a star like Betelgeuse reaches the end of its life. The nuclear furnace at its core runs dry. Nothing remains to hold back the crushing weight of the star's own mass. Gravity wins. The core collapses in a fraction of a second, and the resulting shockwave blasts the star's outer layers apart in an explosion so violent it can briefly outshine entire galaxies. When Betelgeuse finally goes supernova, it will be visible from Earth even in daylight. Not for a moment, but for months. It will shine as bright as a crescent moon in the night sky, the brightest object in the heavens besides the sun itself. Every person alive at that moment will be able to look up and see it. No telescope required, just eyes and a clear sky. That moment is coming. The only question is when. For most of history, scientists believe that question had a fairly comfortable answer. Betelgeuse is near the end of its life, yes, but cosmically speaking, near is relative. Estimates range from a few thousand years to as many as 100,000 years before it explodes. That's a long stretch from a human point of view, long enough not to worry about tonight. Then, late in 2019, Betelgeuse began doing something it had never done before in nearly 2 centuries of recorded observation. It started going dark. Not slowly, not gradually, dramatically. Between October 2019 and February 2020, Betelgeuse lost more than 2/3 of its visible brightness. A star that had ranked among the 10 brightest in the night sky since before recorded history suddenly dimmed so much it was barely recognizable. By February 13, 2020, it was the faintest it had appeared in 200 years of scientific observation. Stargazers noticed. Amateur astronomers noticed. Within days, the story was everywhere. Was Betelgeuse about to explode? Was this the start of a supernova? Were we about to witness the most spectacular cosmic event in human history? The world held its breath. Scientists scrambled, telescopes around the globe swung toward Orion, papers were written, theories flew. Some proposed a cool, dark spot on the star's surface, like a giant sunspot but covering a quarter of the visible face. Others suggested the star's normal pulsation cycle had caused it to temporarily shrink. A few, cautiously, nervously, wondered if this was actually it. But it wasn't a supernova. By April 2020, Betelgeuse began to recover. Its brightness slowly returned, the star went back to normal, and the world exhaled. Then scientists set out to understand what had actually happened. And the answer turned out to be so strange that researchers openly admitted they had never seen anything like it in a normal star's behavior before. Betelgeuse had literally blasted off a piece of its own surface. Here's what happened. A massive convective cell, a bubble of superheated gas rising from deep within the star, much like bubbles rising through boiling water, broke through Betelgeuse's surface and was launched into space. Scientists called it a surface mass ejection. The erupted material wasn't a thin wisp of cloud. It was a plume of hot plasma more than 1 million miles across, traveling at 200,000 miles per hour. A chunk of the star's own surface tore away and was flung into space. Our sun does something similar, though on a much smaller scale, called a coronal mass ejection, when the sun's outer atmosphere throws off a cloud of charged particles. It happens regularly. We even issue storm warnings for it, since strong ones can disrupt satellites and power grids on Earth. What Betelgeuse did was 400 billion times larger. The ejected material moved outward from the star, and as it drifted from the intense heat, it cooled. As it cooled, the heavier elements within the gas, silicates, dust grains, condensed. The gas turned into a thick, dark cloud of dust, one so large it covered roughly a quarter of Betelgeuse's visible surface as seen from Earth, blocking the starlight behind it. That's why the star went dark. Not because it was dying, not because it was about to explode, but because it had blown a hole in itself, and the debris hung in space like a curtain in front of it, blocking our view. Lead researcher Andrea Dupre, an astronomer at the Harvard and Smithsonian Center for Astrophysics, who has studied Betelgeuse since 1985, put it plainly: we had never before seen such a massive ejection from the surface of a star, and there was clearly something going on that wasn't fully understood. A star 650 light-years away had thrown off a piece of itself the size of a small planet, draped the debris across its own face, and left every astronomer on Earth puzzled. Betelgeuse had done something unique in the history of stellar science, and nobody knew why, until very recently, when a new discovery changed the picture entirely. For more than a century, astronomers had suspected something, not loudly, not with certainty, but as a persistent, nagging idea lurking in the background of Betelgeuse research. The star's brightness didn't just vary randomly, it varied in patterns. There was the well-known cycle of roughly 400 days, during which the star pulses brighter and dimmer as it breathes in and out. But there was also a longer cycle, about 6 years, that the pulsation model alone couldn't fully explain. Some researchers proposed that this 6-year cycle might be caused by something orbiting Betelgeuse, a companion star, a smaller star caught in the supergiant's gravitational grip, its orbit tugging at Betelgeuse, influencing its brightness, perhaps even clearing dust from its path and making the star appear brighter to us at certain points in the orbit. But Betelgeuse is so overwhelmingly bright that spotting anything beside it is like trying to see a firefly next to a bonfire. Every attempt to find a companion ran into the same problem. Betelgeuse's light drowned everything else out. Searches were made, nothing was confirmed, and decade after decade the companion remained purely theoretical, a whisper buried in the data. Then, in 2024, 2 independent research teams published papers predicting something specific. Drawing on decades of brightness data, orbital mechanics, and careful modeling, both teams concluded that if a companion star existed, they could pinpoint exactly where it would be in December 2024. That would be the moment the companion reached its greatest angular separation from Betelgeuse, the farthest point in its orbit, and therefore the easiest moment to separate its light from the supergiant's overwhelming glare. A French astronomer named Miguel Montargès, who works at the Paris Observatory, read those papers, looked at the prediction, and decided to take the shot. He booked time on one of the most powerful ground-based telescopes in the world, the European Southern Observatory's very large telescope in Chile's Atacama Desert, and pointed it at Betelgeuse in early December 2024. He used an instrument called SPHERE, originally built to hunt for exoplanets by blocking out the light of their host stars to reveal the faint worlds orbiting them. The same technique, the same tool, now turned toward a star instead of a planet. Montargès spent months processing the images, unsure the instrument was even sensitive enough to catch what he was after. He half expected to find nothing. Then the images finished processing, and he jumped out of his chair. Right beside Betelgeuse, visible in the processed image where the supergiant's light had been carefully stripped away, was a source, a faint point of light, a star, exactly where the models had predicted. Betelgeuse B, the companion, the star that had been hiding in plain sight for 100 years. The discovery was published in July 2026 in the journal Astronomy and Astrophysics, and it came with another surprise. The companion wasn't the size anyone expected. Earlier theoretical estimates put its mass at roughly that of our Sun, but the imaging data showed something different. Betelgeuse B has 2 to 3 times the mass of the Sun, significantly more than predicted, large enough that the planet hunting techniques used to spot it would have missed something smaller. In an almost poetic twist, Betelgeuse B was detectable precisely because it turned out bigger than expected. Had it matched the original prediction, the team might have been searching for something too faint to see. The companion revealed itself simply by being more massive than anyone thought. The companion quickly picked up a nickname, Betelbuddy. And here's where things get even more interesting, because Betelbuddy doesn't just sit there quietly orbiting, it interacts, it leaves a wake. A separate study published in early 2026, using data from the Hubble Space Telescope, showed something remarkable. As the companion star orbits through Betelgeuse's extended outer atmosphere, and it's close enough to be literally inside the supergiant's outer layers, it creates a dense wake of gas behind it. Much like a boat moving through water, the smaller star's gravity drags material along as it orbits, piling it up behind it and carving a visible trail through the atmosphere. Hubble captured that wake directly. The companion itself was generating detectable disturbances in the larger star's outer layers, a gravitational ripple spreading through a sea of stellar gas hundreds of millions of miles across. Scientists now think Betelbuddy may be responsible for the mysterious 6-year brightness cycle. As it orbits, it periodically clears dust from the line of sight between Betelgeuse and Earth, making the star appear brighter. When it shifts to another part of its orbit, the dust builds back up and the brightness dips slightly. A mystery that had puzzled astronomers for generations is now explained by a hidden companion nobody had ever directly seen. And there's a bigger question now sitting on every astronomer's desk. Could Betelbuddy have caused the Great Dimming? Consider the convective cell that triggered the surface mass ejection in 2019. Could the companion's gravitational pull, as it swept close to the surface during its orbit, have triggered or amplified that eruption? Could it have reached into the churning interior of Betelgeuse and set off the chain of events that blasted a piece of the star's surface into space? Scientists aren't ready to confirm that, but they're absolutely asking the question. The paper announcing the companion's discovery explicitly said astronomers are now eager to learn whether the companion could shape Betelgeuse's future evolution, or even how it eventually explodes. Now let's talk about what the James Webb Space Telescope is bringing to this story, because Webb isn't just watching Betelgeuse, it's reading it in a level of detail no instrument in history has ever managed. Webb observes the universe in infrared light, wavelengths invisible to human eyes, but carrying information visible light can't. Dust, the kind responsible for the Great Dimming, is transparent to some infrared wavelengths, while blocking others, meaning Webb can see straight through dust clouds that would completely hide things from optical telescopes. Webb can also measure the temperature of surfaces and gases with extraordinary precision. The images Webb has captured of Betelgeuse reveal the star's surface dynamics in a level of detail simply not possible before. Its surface isn't smooth and uniform like a billiard ball. It roils and churns. Giant convective cells, some larger than the entire sun, rise from the interior, break through the photosphere, cool, and sink back down. The surface of Betelgeuse is an ocean of boiling plasma in constant motion, constantly erupting small plumes and shedding material into space. Astronomers are using Webb's observations to track the movement of gas and dust around the star, to analyze its surface temperature in real time, and to search for the kinds of instabilities that might signal what's coming next. Webb can see the material Betelgeuse throws off, the dust clouds, the gas shells, the intricate debris field surrounding the star out to enormous distances, and it can analyze what that material is made of, giving scientists insight into processes happening deep inside the star, where we can never look directly. What Webb is building, observation by observation, is a picture of a star in the final chapter of its life, a star burning through its remaining fuel, pulsating and erupting, losing mass at an astonishing rate, shedding its outer layers into space over time, surrounded by shells of previously ejected material. Each shell is a record of an earlier eruption, like tree rings marking the centuries. Every massive star that has ever exploded left behind shells just like these. Betelgeuse still carries its shells, and we can study them live. That's what Webb is doing, watching the crime scene before the crime. There's also a Webb discovery from 2025 that reshapes how we think about Betelgeuse's future. In June 2025, astronomers detected a supernova in a distant galaxy called NGC 1637, about 40 million light-years away. Scientists compared before and after images from Hubble and Webb. The star that exploded was a red supergiant hidden behind thick clouds of cosmic dust, so thick that Hubble, which operates in visible light, couldn't spot the progenitor star at all in the pre-explosion images. But Webb, looking in infrared, could see straight through the dust and detect it. It was the first time a supernova's source star had been identified at mid-infrared wavelengths. This matters enormously for Betelgeuse, because Betelgeuse is surrounded by material it has ejected over its long life, including the dust cloud from the Great Dimming. When Betelgeuse eventually explodes, the supernova's light will have to punch through that dust. In visible light, it might look dimmer or distorted, but Webb sees in infrared it will see the explosion clearly through the dust from the very first moment. If Betelgeuse explodes during Webb's operational lifetime, the data we collect will be the most detailed, most scientifically valuable record of a nearby stellar death in the history of science. We're ready for it in a way no generation before us ever has been. Let's talk about what actually happens when Betelgeuse explodes, because the reality is more dramatic than most people imagine. The core's collapse happens in under a second. One moment there's a star, then the core, compressed beyond what any known force can support, collapses. In under a second, it shrinks from roughly the size of Earth down to roughly the size of a city, about 20 kilometers across. The resulting shockwave tears through the rest of the star. The outer layers, hundreds of millions of miles of stellar material, get blasted apart. The explosion begins. From Earth, the supernova would appear as a sudden, dramatic brightening. Within days, Betelgeuse would be visible in the daytime sky. It would cast shadows at night. It would be bright enough to read by. Every person on the planet, in every culture, in every country would see it. No telescope, no app, no equipment needed, just eyes turned to the sky. It would remain visible to the naked eye for months, possibly close to a year. And the remnant, a vast expanding cloud of gas and debris, possibly with a neutron star spinning at its center, would remain visible in our sky for thousands of years afterward, much the way the Crab Nebula is still visible today, nearly 1,000 years after its star exploded in 1054 AD. We are perfectly safe. At a distance of 650 light-years, the radiation reaching Earth would be entirely harmless. Studies show a star would need to be within about 160 light-years to pose any biological risk from a supernova. Betelgeuse is more than 4 times farther than that, so there's no danger. Just the greatest light show in the history of human civilization. So when does this actually happen? Honestly, we don't know precisely. Estimates range from a few thousand years to perhaps 100,000 years from now. Nobody can say for certain. What we do know is that Betelgeuse is behaving unusually. The great dimming was unusual. A surface mass ejection of that scale had never been documented in a normal star before. The companion discovery raises fresh questions about the star's evolution, and the churning visible in Webb's infrared observations shows a star in real internal turmoil. Whether that turmoil marks the final act, or just a dramatic middle chapter, is exactly what scientists are working to figure out. And there's something strange and beautiful about the timing. Humanity has watched Betelgeuse for thousands of years, and for nearly all of that time we simply saw a red dot. Then we built telescopes, then space telescopes, then the James Webb Space Telescope. And right as we finally gained instruments capable of truly reading what Betelgeuse is doing, the star seems to be doing the most interesting things it has ever done. We built our greatest eye, pointed it at the most dramatic star in our sky, and discovered it had been hiding a companion, had erupted in a way never before recorded, had kept a secret that century after century of astronomers had missed, and may be approaching a finale that will write its name across our sky in fire and light. There's one more thing worth sitting with. The light we receive from Betelgeuse right now, the light Webb captures in its infrared detectors, the light amateur astronomers photograph on winter nights, left the star roughly 650 years ago, around the year 1375. The 100 Years' War was underway in Europe. There were no telescopes. There were people looking up at the very same red star we look at tonight, and the light they saw, and the light we see, left the star in entirely different eras. And here's the reverse. If Betelgeuse's core collapses tonight, this very moment, we wouldn't see the supernova for another 650 years. The light is either already traveling or hasn't been emitted yet, and there's no way for us to know which. That supernova could already be on its way, and we simply haven't gotten the news yet. That's not a frightening thought, it's a humbling one. The universe runs on timescales and distances that make our entire human experience feel very small. And yet here we are, a brief, fragile species on a small planet orbiting a very ordinary star. And we built the James Webb Space Telescope, pointed it at a dying giant 650 light years away, found its hidden companion, and are watching in real time as it approaches its end. Whatever Betelgeuse is doing right now, erupting, pulsing, tugged at by its companion, shedding its outer layers into the dark, we are, as far as we know, the first beings in the history of the universe watching closely enough to understand what we're seeing. That star has been dying for millions of years, and we've finally shown up to witness it. Drop a comment. Tell me, did you know Betelgeuse had a hidden companion? Did the great dimming in 2019 make you look up? Let me know. Share this with someone who needs to look at the sky tonight, and I'll see you in the next one.